Alright, let's go and take a look now at the quotient rule for derivatives. So again, it's just another rule that allows us to find the deriv of more types of functions. So let's say, for instance, we have something like this. Y is equal to cosine x over x squared. So here's an example of a quotient, where we're dividing one function by the other. Okay, so let's see here. Now the quotient rule looks like this. If you have two functions divided by one another, f of x over g of x, the way you take the derivative using the quotient rule, you do the bottom times the derivative of the top, so in this case it would be g of x times f prime of x, minus the top times the derivative of the bottom, so f of x times g prime of x, all over the bottom squared. Okay, so again, that's the quotient rule right there. And I just think of it, bottom times the derivative of the top, minus the top times the derivative of the bottom, all over the bottom squared. So let's apply it to this problem right here. So some people like to, think, okay, let me think of the top function as f of x and actually write that out. Let me think of the bottom function as g of x and actually write that out. And then go ahead and find f prime and g prime from this. So in this case, f prime of x, the derivative of cosine would just be negative sine of x. Okay, oops, sorry, didn't write that too well. Negative sine of x. The derivative of g, which is x squared, would be equal to 2x. Okay, and now I can just kind of fill in everything where it's supposed to go over there to find the derivative of this function y. So y prime would be equal to g of x is x squared times f prime of x, which right here is negative sine x, so I'll just write that as negative x squared sine x when I multiply x squared times negative sine x, and then minus f of x times g prime of x, so it's going to be cosine of x times 2x, so it's going to be 2x cosine x, okay? And then all over the bottom squared, which is x to the fourth. Okay? So yeah, that's the, using the quotient rule to find the derivative of that function. Alright, so now, I do want to mention here that you do have another option on this. So I could have, if I wanted to, from the start, rewritten this as like cosine x, and then brought that x up to the top as x to the negative 2, and then I could treat this as a product rule, cosine of x times x to the negative 2. And I could use the product rule to find the derivative. It would look a little bit different, but if you simplify it, you could show that it's the same thing. So just want to throw that out as an option. Sometimes this option up here, where you change it to the product rule, might be easier. Sometimes the quotient rule might be easier. It's just sometimes personal preference too. So just want to show real quick here an example of somewhere where you could use the quotient rule, but it's going to be more work to do so. So I've seen people on a problem such as this, apply the quotient rule to this, which is fine. You can use the quotient rule for this and get the correct answer to find the derivative. But, it would be much easier, in my opinion, to rewrite this as 5x to the negative 3, and then you can just use the power rule, and you get your derivative very quickly. So it would be negative 15x to the negative 4. So, again, there's just an example where probably your best bet is to just rewrite it as opposed to using the quotient rule.